All right, good morning and welcome back. Today is our final lesson on Chapter 12. Then Thursday we will have a review, and Friday will be our quiz over Chapter 12. So if we look here, this first section, we are going to use the Pythagorean theorem. Now, you have heard of this at some point, I'm guessing, but if you don't remember, this tells us that a squared plus b squared equals c squared. Now, it's important to remember the c squared has to be the hypotenuse, also known as the longest side or the side opposite of the right angle. So if we look here at the first example, c will be the x. It is opposite of that right angle. It is the longest side. So it doesn't matter which one's a or b. We'll have 4 squared plus 3 squared equals x squared. 4 squared is 16. 3 squared is 9. Okay, we'll add those two together. 25 is going to equal x squared. Take the square root of both sides. We'll get x to equal 5. Okay, now, because both 3, 4, and 5, all of them are whole numbers, this is known as our Pythagorean triple. Okay, this happens anytime all three numbers are whole numbers. All right, example B here, same idea. This time we are missing this side, so I'm going to put an x over there. And 12 has to be our c. So it's 11 squared plus x squared equals 12 squared. 11 squared is 121. And that will all equal 144. Okay, we'll subtract the 121 now. If you don't have these memorized, just use a calculator. Remember, 11 squared means 11 times 11. 12 squared is 12 times 12. Okay, we'll get x squared equals 23. Square root of 23 is not as nice. If you're using your phone, you usually have to turn your calculator sideways to get the square root. If you're using this, I recommend if you're on a Chromebook, use desmos.com/scientific. We can do the square root of 23, and if we round the nearest tenth, we'll get 4.8. So this would not be a Pythagorean triple because two of them are whole numbers, but the third one is not. All right. So on to the next one here. As we look at this next section, it says right triangle similarity theorem. Okay, this idea is anytime we have an altitude to the hypotenuse of a right triangle. So what that means, altitude is when it goes from one corner, one angle, to the opposite side and forms a perpendicular line with it, or it forms a right angle. So not only is that a right angle, this one also is. So that altitude goes to the hypotenuse. H is our altitude here. Anytime that happens, it forms two triangles that are similar to each other and to the original triangle. So if we think about it, you don't necessarily need to write this down, but we have our large triangle here. Okay, and then we also have right here, if we would rotate this around, this is our medium triangle. And then right up here is our small triangle. And all of these will be similar to one another. They'll have a right angle and they will all be similar to one another. So, once again, we don't necessarily need these pictures, but the reason this is helpful is then if we have some pieces of information here, we can easily find out the missing sides. So one thing to keep in mind is like d over h. If I had d over h, this would be equal to h over e. Now, if you're not sure why, think about it. If I had this small triangle and I rotated it, okay, counterclockwise, it would kind of match up. This h would match up with the e. The d would match up with the h. Notice h and h, the altitude is going to be on the diagonal from each other. Now that's one example. Now another one, sometimes you might instead have like d over a. So d over a, this is still in the small triangle. This is the short leg and the hypotenuse. That would equal, and then we could do a over c. So for the large triangle, that's the short leg and the hypotenuse. Once again, on the diagonal, we have a and a. Okay, the final one that I'm going to show is if we had e over b. So that's for the medium triangle. That would equal then b over c for the large triangle. So example 3 here says, given the right triangle ABC with altitude BD drawn to hypotenuse AC. So here's your altitude. It says if AD is 18 and BD is 6, what is the length of AC? So we need this whole length from A to C. We know from A to D is 18, so if we can find what this chunk is, we can add them together. So let me put an X there, and we know then that if we can find what that X is, we can easily find what AC is. So to find that X, think about the small triangle first. We have 6 and X, so if we would do 6 over X equals, now once again, if this would rotate, that X would rotate up to the 6 would rotate up to the 18, so 18 over 6. Notice the altitude forms the diagonal, 6 and 6. So we cross multiply, 18x equals 36. Divide by that 18, and we will get x equals 2. And we'd be done. Except that's not the answer to the question. The question is, what is AC? So we need to do 2 plus 18, which gives us 20. And we are done now. All right, a few more. This next one says find the length of AD. So AD is right here, the altitude. We know that's the altitude because it forms a right angle. Okay, and BD equals 3, DC equals 12. Once again, on this one, the large triangle we don't have enough information about. The large triangle would have a hypotenuse of 15, but I don't know what either of these sides are. On the small triangle here, I have 3 and x, so if I put 3 over x, it will equal, so 3 over x would equal x over 12. Cross multiply, x squared equals 36. We need to take the square root of both sides. Square root of 36 is 6. All right, 2 more examples. And one way you can kind of visualize this, Delta Math does it. I want to maybe see if you can visualize this. If you're trying to find for this x, if I run the animation, you can watch. You see how it rotates these around, and now you can see that the 11 and the 33 match up, the 33 and the x match up. Meanwhile, both of those match up here. AB matches up with AD and BD. So one more time, let me show you. And it kind of flips them around. It might be easier for you to visualize if this just turns on this point D here. If it rotates there, then this 33 pops up to the X, the 11 pops over to the 33. Okay, so on to the next one. And here we are trying to find what the length of AD is. So let me put my X there. We have our medium triangle. So if I do X over 16, then match that up with the small triangle. So that'll be 16 over 8. Cross multiply, we'll get 8x equals 256. Divide by 8, we get x equals 32. Okay, now the last one, probably the most difficult, so watch closely. Here we're trying to find 3 sides, not just 1, but 3. So at first, it looks kind of like there's nothing to do. But keep in mind, if this is an altitude, not only is there a right angle there, there's also a right angle there. And that means this small triangle is a right triangle. We have an x there, 18, 30. Okay, so we can do a squared plus b squared equals c squared. Now the c has to be the 30. I know some of you might be thinking, but the 30 is not the hypotenuse of the big triangle. You are correct. Of the big triangle, the hypotenuse is here. But on the small triangle, the hypotenuse is the 30. So x squared plus 18 squared equals 30 squared. Get 324 and 900. Subtract that 324. Take the square root of both of those. Square root of 576 equals 24. Okay. Now for the red. For y. So, let me first fill that in. This is 24. Okay, to find y now. I could do y over 24. If I do that, I will set this equal to 24 over 18. You see how y over 24 is on the medium triangle. If we rotate that, it matches up with 24 and 18. Cross multiply, we'll get 18y equals 576. Divide by 18. Y equals 32. And now, if we know that's 32, that means this whole thing, 18 plus 32, that whole thing is going to be 50. So we can once again use Pythagorean theorem. This time the 50 will be the c. So you'll do 30 squared plus z squared equals 50 squared. So 30 squared is 900, we already know, plus z squared equals 2500 or 2500. Subtract 900. And z equals 40. All right. If you have any questions, let me know. There is a Delta Math assignment, so please get that done. Hope you guys have a great day. Bye.